is momentum conservation. Part A. Initial momentum will have to be equal to the final momentum. Initial momentum is pretty straightforward. Initial mass of the rocket times initial velocity, which we know both of, and that will be equal to mass of mass of one section times velocity of that section plus mass of the second section times velocity of that section. So these are equal mass sections. So this is m times v1 plus v2. Okay. Now we're given that the relative velocity is 2,800 meters per second. And so since we have relative velocity, let's say we can substitute v2 for v1 minus vrel, or relative velocity. Okay, so one of the velocities will be separate from the other one by subtracting, separated from the other one by subtracting the relative velocity from it. Okay, and so what we have is, and so we want v1. So here we have 2 times, okay, we have 2 times m v1 minus m vrel, or relative velocity, is equal to mi vi. So right, so v1 therefore is just mi vi, initial momentum, plus mass of the mass of one of them, m, over m times relative velocity over 2 times m. Okay, and so initial mass is 925 kilograms times initial velocity is 6,600 meters per second. 925 over 2 kilograms, because equal mass sections, times relative velocity, which is 2,800 meters per second. You divide that by 2 times 925 over 2. As a matter of fact, you know what? Let's move to the next page to continue with this. V1 is equal to 925 kilograms times 6,600 meters per second, plus 1/2 of 925 kilograms times 2,800 meters per second over 2 times 925 over 2. In other words, 925 kilograms. And what you get is 8,000 meters per second. And this is away from the Earth. So V1, one section is moving at 8,000 meters per second away from the Earth. Therefore, V2 is just V1 minus vrel. So that's 8,000 minus 2,800, which is equal to 5,200 meters per second, again, away from the Earth. Okay, so that's part A. And for part B, we use energy conservation. And so what we know is that the final kinetic energy that we get is equal to the initial energy plus the energy that's put in. That's E, and that's what we're after. So E is just a change in kinetic energy, or K sub F minus K. And so final kinetic energy is 1/2 times m, which is 925 over 2, times v1 squared minus v2 squared. Okay, and initial is, of course, 1/2 times m initial times v initial squared. And so this is 1/2 times 925 over 2 kilograms times 8,000 meters per second. Whoops. squared minus 5,200 meters per second squared minus 1/2 times 925 kilograms times 6,600 meters per second was the initial speed squared. And so we get about 9.07 times 10 to the 8 joules, or 0.9 gigajoules. And that's it.